All right, yeah, let's start here with talking about equations that are going to be in slope-intercept form. And we want to graph them. Previously, the equations that we've graphed were in standard form, and we did use a table. We used the x and y intercepts, which that's okay to use for this as well. I mean, tables and x and y intercepts, all good on just about any equation you want, but equations of lines. But yeah, what if what if our equation is in slope-intercept form and we want to graph it? And let's think about another way of doing that with what we've talked about just here recently. Okay. First of all, we do note, is this in y-intercept, slope-intercept form? Yes, it is. Y equals mx plus b form is what we're talking about. This is in slope-intercept form. And since it's in slope-intercept form, y equals mx plus b form, I can read two bits of information right off of that equation, can't I? What does this line have? What can you tell me about this line? Well, that's the m, so that's the slope, okay? Slope is 2. That's the b, so the y-intercept is b, that's -7. Okay, well, yeah, if you really get to thinking about that, that information is similar to a problem we had previously, and that is we've got a point and a slope. Can I graph this line based on that? We know it's a line. So I can graph this line using that information. The y-intercept being -7, well, that tells me that it's going to cross my y-axis at -7. -3, I think there's -7 right there. So we have a point right there at -7. Okay? Now the slope being 2, how can I get another point out of that? That's the rise over run, isn't it? The slope is 2, which is my rise over run. Just have to make it that be a fraction, which just put it over 1. So the slope being 2, or 2 over 1, my rise is 2, my run is 1. Can I get another point from here? Rise 2, run 1. There you go. There's another point right there. 2 points to determine a line. We know we've got a line. There you go. So if we've got it in y equals mx plus b form, I went through it a little slower than usual, but that's an easy way of graphing those. If I have, say, y equals, a negative 3x plus 4. Yeah, again, I've got the m is -3, the b is 4, the b is the y-intercept. 1, 2, 3, 4, it's right there. The m is -3. Well, that's over 1, right? So rise -3, run 1, down 3, over 1. 1, 2, 3, over 1. There you go. There's another point. Down 3, over 1. So there's your point. How's that? The second point, do you need to put the coordinates down? Is that what you're saying? Or you don't have to, just as long as it, you've got it marked accordingly. Yeah, you don't have to label it. It'd be 1, 1, but no, do you have to label it? No. Just be sure I can tell where it is. Okay? All right. Got one more. What about y equals, let's say y equals 3/4 x. Well, y equals 3/4 x. Is that in slope-intercept form? Yes, it is. Missing a part there, but we can fix that. Yeah, but this is in y equals mx plus b form, the slope-intercept form. It's just that the b, well, is not written up here. However, there is a value of b I can put in there. What could I put the value of b to be? I've got the m. Yeah, the b could be 0, couldn't it? If I just put a plus 0 here, that's the equivalent form to that, isn't it? That would be equivalent, because adding 0 doesn't add anything to it. However, it helps us in this case because that'll tell us our b. So we can graph this one. So we've got an m is 3/4 and b is 0. Yeah, just add that 0 in there to that. And so what does that mean the equation, graph of the equation is going to look like? Well, if I go to the b is 0, where does that happen to be? It's right there at the origin, isn't it? B is 0, the y-intercept 0, so that's right here. Then my rise over run is 3/4. Rise 3, run 4. That put me at 4 there. There you go. Goes through that point, then through the 0. There you go. Okay? All right. Any question, concern, problem you see there? Okay? All right. Let's take a look at a related topic here. Let's talk about finding the slope of a line in standard form. We've talked about the slope-intercept form, and we've talked about the standard form. Well, what we said about the standard form is you can't read the slope right off of the equation like you can the y equals mx plus b form. So let's talk about what we do if we want to find the slope of a line that's in standard form. If I have, let's just make it 4x plus 10y equals 13. 4x plus 10y equals 13. I'm interested in the slope of this line. Well, unfortunately, I can't say slope here is 4 because to read the slope right off the graph like that, we have to have y equals mx plus b. This is the standard form, so it doesn't have y equals an expression over here. We've got other stuff with the y term, y part. Well, different ways we could do that. I mean, we could go through the whole slope formula thing, but that would mean we'd have to get 2 points and we'd have to go through the slope formula. Now, the easiest way to do this one is to change this form to slope-intercept form. Can I adjust this just like we could change the slope-intercept to standard form? We can change the standard form to slope-intercept form, can't we? Now, what does that entail? What would that mean? I need it to be y equals, don't I? I need to get the y term, the y variable, on a side by itself. That's what that means. So I need to take this equation and get y by itself. All right, so we've done that the other equations before. This is similar. I need the y term, first of all, to be by itself. So that would mean move the 4x term, move it to the other side. What would I do? Subtract it. subtract 4x from both sides, because that'll get rid of it there. So I'd have 10y equals, now, can I combine those? Not like terms, so those can't be combined. Let's write it, write the x term first, then the 13. I can't combine those, so I'll just have to say it's minus 4x plus 13. But I do need the y by itself, so I need to divide off by 10 on both sides. And I will have the y by itself. Now, this 10 does divide both of those, so it'd be negative 4x divided by 10 and 13 divided by 10, which doesn't reduce, but this does reduce to be negative 2 over 5. Reduce those by 2. So here I wind up with y equals, so I wind up with y equals negative 2/5 x plus 13/10, which goes a long way to answering our question. The question was, what's the slope of this line? Well, now I know. What's the slope of this line? Negative 2/5. Yeah, now I can read the slope right off of it. The slope is negative 2/5, the m. Okay? All right. So let's say find the slope of the line uh, 6x minus 6x minus 5y equals 15. Find the slope of the line, 6x minus 5y equals 15. Well, if all I'm interested in is the slope, I can do that by getting the y equals mx plus b form. Change it to y equals mx plus b form, like we did there. Get the y on a side by itself. So I would, first of all, do what? Subtract the 6x. Now don't forget to bring down your minus. That minus 5y, the minus comes with it. 6x go out, but the minus 5y stays. So minus 5y equals minus 6x plus 15. Then I divide off by minus 5. So that's y equals, and then that minus 5 divides both of those. So what do I wind up with here in this case? Y equals, that would be a positive 6/5 x, and that would be minus 3. 15 divided by negative 5 is negative 3. There's my slope. Okay? Now, some people realize, and if you want to do this, this is fine too, but this also gives us another way then of graphing this. I mean, this, previously, we graphed this, we did either a table or we did the intercepts, get the x and y intercepts. Well, if we have to go through this process anyway, and then we're told, well, what about the graph of that? Can't we graph off of this? Either one, we can graph off either one, but yeah, we can use this, if you want to go ahead and graph this, because I can use the y-intercepts negative 3, the slope is 6/5. I could graph it that way, just like we were just doing. So, all right. Any problems or concerns? All right.